You must be wondering, what a stupid title. And yes, it is stupid. The purpose of this video is to explain shark movement. On the internet, you'll read so many theories on their swimming that it can become confusing. This is a theory that we like. You may have noticed that fish have symmetrical bodies while sharks don't, and there is a reason for it. Fish have something called a swim bladder. It's basically a thing that they inflate to go up and deflate to go down. Sharks, however, don't have swim bladders, so if they stayed in one place, they would sink and also drown. Oh yes, sharks breathe using something called ram air ventilation. They can't suck water to breathe, so they have to move all the time, but they don't complain. It keeps us fit, they say. So let's get to it. You might have noticed that sharks have weird tails, like this one, or maybe even this one. You can see that the upper fin is larger than the lower one. So basically, if they wave that thing, they would be pushed down because they would exert more force above their center of mass. But as we've been able to notice, sharks aren't constantly swimming down. Oh no, take a look at their bodies. Seriously, take a look at it. Don't they resemble an airplane wing? They have a flat belly and a curved upper body. That makes them generate lift. What is lift, I hear you not say? Well, let me explain. Even though you probably already know, just give me a second to Google it. Imagine an airplane wing. Actually, you don't have to imagine it, it's right there on the screen. Now, let's draw two lines that represent the airflow. There we go. You can see that the upper line is longer because of the larger curve. That means that air that is on top has a longer way to travel. Since air particles both on the upper and lower side take the same amount of time to get past the wing. That means that particles on the upper side of the wing have higher speed than the ones at the bottom. If you do some math, according to Bernoulli's principle, it would mean that the high-speed particles generate low pressure, unlike the low-speed particles which generate high pressure. The difference in pressure generates lift. Now, let's just get off topic for a second to talk about two very interesting things which aren't really related to this topic: helicopters and Formula One cars. Helicopter rotor blades are basically wings that you spin to generate lift. Here's the interesting part. They pretty much always spin at the same speed. You might be wondering, how is it possible for them to go up and down if it's the same speed all the time? Simple. They change the wing's angle of attack. Here's something even more interesting and even more unrelated. You already know that a helicopter rotor tilts to make the helicopter go forwards, backwards, left, and right. But to make it go forward, you don't tilt it forward. You tilt it on its side. Why? It's got to do with the dynamics of spinning. We won't spend much time explaining it, but if you push the rotor on its side, the force will be noticeable 90 degrees later. I know. Awesome. Now, Formula One cars, mainly their rear wings. They're pretty much upside-down airplane wings, pushing the cars into the ground. The only difference is they have a bit different shape, so when the air is flowing past, it hits the wing and pushes it even more to the ground. Finally, we can get back to sharks. Does the shape of their bodies look like an airplane wing to you? So the theory is that their tails push them down while the lift on their bodies pushes them up. We won't make this video longer than it needs to be, so that's pretty much all you have to know. Bye! Thanks for watching. Like and share if you enjoyed it, and subscribe if you want more of this stuff. See you in the next video.